mudnayd adaa maraye.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. أولا السلام عليكم ورحمة الله وبركاته. Dhammaan ardayda for Today Secondary School waxay noo sii socday oo continuous inoo ahaa for Chemistry chapterkeeni saddexaad insha Allah. Waxaynu ka soo hadalnay markaa xiisadii iskuulkeen dambeysay waxyaabihii moleculeska ahaa oo waxaynu ku guda jirnay markaa wixii la odhan jiray Covalent bond. So covalent bond waxaynu kaga soo hadalnay xiisadeenii ugu dambeysay afar example markaa mid kamid wuxuu ahaa hydrogen, markaa wuxuu ahaa midna waxa ahayd chlorine, oxygen iyo nitrogen. Afarta example waxaynu kaga soo hadalnay inuu ahaa our previous lessons that we have already studied as molecular elements. So we talked that the whole bonds that are together for this molecules was a covalent bond. So most of them they was diatomic elements. So if we look for hydrogen, it's diatomic elements, and the bond of present will be what we call it covalent bond. So chlorine was existing diatomic, and the type of bond that was present was covalent bond. So oxygen similar, nitrogen was covalent bond was present, but triple bond will hold together. So covalent bond itself, if we briefly recall for our previous lecture or our previous lesson, covalent bond itself can be divided or can be classified into three main types according to the existence. So if a covalent bond can exist, as we have already mentioned, single bond, which will be element, single bond element, and also double bond. It means element, double bond element, like oxygen. And also it can exist a triple bond, like nitrogen. Triple bond nitrogen, triple bond nitrogen. So that was our previous lesson for brief recall. So today we are going to look for molecular compound. So in simply, molecules can be classified or can be divided into two main categories. As we have already said, molecule can be divided into two main categories. The two main categories are including molecular elements and molecular compound. So molecular compound are more different than the molecular elements. So the main difference will be the elements that they are composed or consist of. The element that they are composed and existed of. So today, molecular compound will exist or will be existed more than two elements that are combined together. For that elements, there is no condition that are held together for this compound. The elements can exist more than two elements that will be different. But as our previous lecture, molecular element can exist the same elements like hydrogen, oxygen, nitrogen, chlorine, and so on. But this will be different from that. Okay, this will be different from that. Molecular compound. In molecular compound, atoms share outer electrons. In this compound, atoms means the elements share outer electrons. The valence electron, they share the valence number of electrons with a different. They are not similar. Different means they are not similar. With a different to form molecules. They are different and then form molecules. But that molecules, it's not a condition that they become a similar elements. Okay, they can be a different. That molecule can exist in different. Each atom obtains. Gains an outer shell of electron. An outer shell of electron, it means full outer shell electrons. Each element will gain outer shell of electrons like noble gas. Each of the atoms that are shared electrons will gain full outer shell electrons like noble gases. Because noble gases, their outer shell are full almost. Like noble gas atoms has For example, in this diagram shows ammonium. This diagram shows ammonium, and the below one shows ammonia. So the difference between ammonia and ammonium are their existence. The existence of ammonia are one hydrogen and four hydrogens. So nitrogen. So this nitrogen will bound these four elements, these four hydrogen elements, and each element that are including for this compound are holding together or combining together will gain full outer shell electrons like noble gas atoms has. Okay, so each one full shell. So full shell, it does not mean only that the elements contain 8 electrons for their outer shell, but it means that it become unstable. So similar with that, this is another element. Okay, this is another compound which is called ammonia. Ammonia will contain one nitrogen, another 3 hydrogen. So what this line indicates you, this line indicates you the covalent bond. This line indicates you covalent bond, and this indicates you covalent bond, and this indicates you covalent bonds. So this nitrogen bonded with these 3 other hydrogens. So each element that are included for this compound will be full outer shell electrons at its own positions. So all these hydrogens become full outer shell electrons, and they behave like noble gas, or say helium. A nitrogen will be similar with them because it requires 3 electrons to gain, and then it becomes a full outer shell electrons, and it behave like noble gases because it obtains its full outer shell electrons. The third example will be water. So water composed of 3 elements that are combined together by the presence of covalent bond. So that elements are 3: oxygen, single bond of hydrogen, oxygen, another hydrogen, single bond. So this oxygen combining 2 other hydrogen atoms. So each element that are including for this compound of water become full outer shell electrons. So hydrogens become full outer shell electron, and this other hydrogen become full outer electrons, and this oxygens become full outer electrons. If we briefly close to this definition this hydrogen required 1 electron, so it shares another electron with this. So this hydrogen requires 1 electron to become full outer shell, and also it gains 1 electron from this hydrogen, from this oxygen elements. So this oxygen itself requires to have a full outer shell electron to obtain 2 extra electrons, and that 2 extra electrons come from the side of these 2 hydrogen atoms. So these hydrogen atoms will share 2 electrons with this 1 oxygen atoms, and this formation happens like what we call it molecular compound. So if we are going to talk what we are calling molecular compound, you should remember that there is more than 2 elements that can be different and combined together by the presence of covalent bond. You should remember for that last point we are talking about. So the next example will be including this compound. So this compound also including what's so called molecular compound. So how can you clarify that it's a molecular compound and it is a molecular element? You can clarify that this is more than 2 elements that are different and combined together either by the presence of single, double, and triple bonds. So these are more than 2 elements different that are combined together. This is a carbon. It shares 2 electrons with this hydrogen, with this oxygen, and also this carbon shares 2 electrons with this other oxygen. So this oxygen gaining the 2 electrons from this, and this hydrogen also, this oxygen also gaining another 2 electrons from this carbon. So this carbon requires completely to have 4 extra electrons to become full outer shell electrons. So it gains 2 electrons from this oxygen at the left side, and also it gains another 2 electrons from the oxygen which are another side, So it obtains these 2 electrons and these 2 electrons by the presence of what covalent bond, So this covalent bond also have another characteristic which is called double bond. So double covalent bond will be present. This oxygen requires 2 electrons and 2 electron will be gained from this. And also this oxygen required 2 electron, and that 2 electron will be required and will be gained from the side of carbon elements. So overall, this is a molecular compound. The next point today we are going to talk will be dative covalent bond. What's called a dative covalent bond or coordinate bonds. Okay, dative covalent bond and coordinate bonds are similar bonds that are existing in a covalent bond, as name indicates you. So there is a things to be remembered or required to remember during this dative covalent bond or coordinate bonds. A dative covalent bond other means coordinate bonds. So coordinate bonds and dative covalent bonds are similar or just same meanings. So the definition of this will be dative or covalent. If you say dative covalent bond or if you say coordinate bonds, they are just same. So this is one in which one of the atoms supply both the sharing electrons. Okay, one of the elements which are the one who donate electrons will be supply both sharing electrons to have covalent bond. One atom will be the supplier of the electrons. So dative covalent bond is written as like this. A dative covalent bond is written as this. Okay, A to B. Okay, there's an arrow here. So sorry. So A to B. So it came from A to B side. A to B side. So A will be the donating electron or supply of electron. So B will be the receiver of electrons. This is the donor of electrons. This is the recipient of electrons. What the direction of the arrow? Direction of the arrow will be from the A side to B side. From the A side to B side. What the direction of the arrow shows the direction in which the electron pair is donated. Okay, donate it means gives. Okay, donate it means gives. For A elements give electrons to B elements. The meaning of it that including for this will be like this. A elements can give B element for an electrons that B requires. Okay. In coordinate or dative elements, the atom that accepts the electrons, the atom that gain electrons means. Okay. During or coordinate or dative covalent bond, the atom that accepts the electrons. Pairs is an atom that does not have filled outer main shell of electrons. It does not contain or it does not have full outer shell electrons. So the atom accepts the atom that gain electrons. So pair means the addition of electrons that or combining of electrons from the two elements that are combined together. We say that atom is electron divisions. The atom that accepts electrons are always in divisions of electrons. So the points that are included for this will be the accepting electron elements are electron divisions already. Right? Electron divisions in already. So don't forget for these 2 points. And in here we are going to specify for the what we call lone pairs and coordinate bonds. So we look for a coordinate bond. So what's called for coordinate bonds? The atom that's donating electrons has a pair of electrons. The atom which donate electrons, the atom that donate the electrons has a pair of electrons. It has a pair of electrons to share to become an outer full electrons, and that's not being used. For that electrons is not already being used in a bond called lone pairs. Lone pairs means the bond that does not use it still. The electrons or pair of electrons that does not take part for the reaction, take part for the covalent bond, that take part for the reaction of the combined element is called a lone pairs. For example, ammonium ions. Ammonium ions exist like this. This plus indicates that this is going to be lose 1 electron from their outer shell electrons. So this ammonium ion is formed when the ammonium bonded ammonia bonds with proton hydrogen ion. So it lose 1 proton hydrogen ions with bonded the electrons, combine this one. So it can exist like this. After this ammonium ion lose 1 electrons, it become this one. Because of it is NH4 and it lose 1 hydrogen ion, this is this, and it becomes NH3. It becomes NH3. So with both the with both the bonding electrons combine this. So note that the ammonium ion has 3 covalent bonds. Ammonium will be having a 3 covalent bonds. It can the bond will be exist in 3 forms. One dative covalent bond, okay? One dative covalent bond. So in here we are going to look the coordinate bond, the coordinate or dative bond along pairs. Okay? For this diagram, look. This is what? This is an ammonia. This is what? This is an ammonia. NH3. So this NH3, 3 hydrogen, okay? 3 hydrogen atoms are bonded to what's called nitrogen. So this nitrogen will be, as we have already mentioned for the previous section, is this nitrogen elements will donate electrons to the hydrogen elements. So these hydrogen elements are already in electron deficiency according to the what's called nitrogen. And nitrogen will be donate, and this will be the acceptor of electrons. So what does mean these 2 dots? These 2 dots means indicates when hydrogen put its electron in here and nitrogen puts its electron here, so they are combined in here for what we call it 2 electron sharing, and here 2 electron sharing, and here 2 electron sharing. So this bond will be called bounded bonds. So this will be called a bounded bonds. So what does mean lone pairs? Lone pairs is electron that does not use or take part for the reaction. So these 2 dots are the electrons of nitrogen that does not take part for the reactions, because there is no other elements that are combined or that are binded in this side. So they are alone. It means lone means alone. Okay, lone means alone. Pair 2. These 2 electrons does not take part for the reaction. There's no anything that are combined them. So this diagram indicates as coordinate or dative bonds. Coordinate or dative bonds, as the name indicates you, the coordinate means the combined elements, bonds that can exist for in between the elements that are existing. So in here, as you see, this is called coordinate bonds. This is outer electron, this is outer electron, so this is the sharing electron, and the bond that present in that side will be the coordinate bond, or so called a dative bonds. So our lesson of today will be there. So I'll see you again until next time, inshallah. Khair baan idin rajeynayaa. Ilaahay xabnada iyo balaayoyinka inaan garamariyo dhammaanteen caafimaad bashbash barwaaqo inshallah. Assalamu alaikum warahmatullahi wabarakatuh. Until next time, inshallah. See you.